Welcome to qnawire.
Now, at the 0.1 significance level, is it reasonable to conclude that the modification reduced the number of traffic accidents? So in part A, we're needing to state the decision rule. And so you would reject the null hypothesis if T is, which is our test statistic, to 3 places. Well, significance again is 0.1. The degrees of freedom, if we're analyzing 8 intersections, the degrees of freedom is 7. So you'd have to look up with a T distribution, and this would be left-tailed based on this hypothesis. So with 7 degrees of freedom with a significance of 0.1 to 3 places would be negative 1.415. If our test statistic is less than negative 1.415, we will reject the null hypothesis. Now, the value of the test statistic is calculated as the mean of the differences divided by the standard deviation of the differences over the square root of the number of pairs. So the mean of the after minus the before is negative 4.25. You're finding the differences between each pair at each intersection and then taking that average, adding them up and dividing by 8. You come out with negative 4.25. The standard deviation of the differences is 5.148. And there are again 8 pairs. And so the test statistic to 3 places is negative 2.335, which is less than negative 1.415. So in part C, the decision would be to reject the null hypothesis. There is sufficient evidence to reject. The mean number of accidents is I don't know what your drop down would be there, but decreased or reduced. I don't know what that might be, but it should be something about going down. The p-value to 4 places using either the T distribution table or there's a lot of p-value calculators out there, but you want to do this from a t-score of negative 2.335 with 7 degrees of freedom. And being one-tailed. And that is 0.0261 to 4 places, which is less than our significance of 0.1, which would also lead to rejecting the null hypothesis.